connecting math, history, and technology. My name is Kelly Remijan. I am a director at large for the Illinois Council Teachers of Mathematics, and I am director of STEM for the ROE 40. With me, we have Mr. Pat Young, who is the Illinois Math and Science Academy Innovation Hub Manager based in Carbondale at SIUC, and he is also a curriculum and PD specialist, and we're actually former colleagues. Beyond my current work with ROE, I was also a PD and curriculum specialist with IMSA as well. So we're going to go ahead and get started. So the first thing I'd like you guys, we're going to get you guys doing something. If you could go to this link, and Pat, if you could help me out here, coolmath4kids.com is the URL, www.coolmath4kids.com. And you can do backslash manipulatives backslash pattern dash blocks. Or if you just go to coolmath4kids.com, you can then click on manipulatives and then click on pattern blocks. What I'm showing you here is an activity that can be done with technology, but this also could be done without technology. It could just be done with actual pattern blocks that you may have in your classroom. And so this could be done, it may seem childish if you're teaching high school, but this activity could be done across levels. It could be done pre-K all the way up to 12th grade. So once you're at this link, you're going to then, what you could have is have one student is going to be at their computer or with the pattern blocks, and then another student is going to be explaining in words, explaining using math terms, how to build something. The student that has the computer does not know what they're building, what they're making. They have to really listen and follow directions. And so I'm going to give you an example of following directions and see if you end up with what I, in fact, wanted you to end up with. And this activity is a great intro into what we're talking about today, but this same kind of activity with different objects can lead into different lessons, different subjects or topics that you're wanting to highlight. So here we go.
First thing you're going to do is you're going to bring down a blue rhombus so that it's at the bottom portion of the screen. We want to have a total of 8 rhombi or rhombuses that are all connected, that are horizontal. So to do that, I could use a copy tool, which is found in the left vertical orange bar of our screen. And that copy tool looks like almost 2 square pieces of paper. If we click the copy tool, we'll be able to copy this blue rhombus. And we can do that several times so that we have a total of 8 rhombi that are all connected, but they're sitting in a horizontal manner. After we have 8 rhombi, we're going to bring down a red trapezoid so that the longer base of this red trapezoid is going to be sitting at the top of the second and third blue rhombus. So we're going to bring down a red trapezoid so that it's sitting on top of the second and third rhombus. We're going to bring down another trapezoid as well, and we want it so it's sitting on top of the fourth and third rhombus from the right. Between these 2 red trapezoids, we want to put another trapezoid, but to have it fit, we're going to have to rotate the trapezoid so that the top base is going to be longer than the bottom base. So I'm going to bring down a trapezoid and I'm going to rotate it so that it's going to fit in between those other 2 trapezoids. So again, I have 8 rhombi and I have 3 trapezoids creating an object.
Now I'm going to stop there, but you could continue doing this. For this time's sake, I'm going to stop. But this is a great way to have students use vocabulary. And this kind of also is, uh, it kind of leads into computer programming. There's certain stages you have to explain. This is a great verbal with math literacy. Again, explaining. So one student would be explaining. If you're at a desk with actual pattern blocks, you can have a folder that blocks. And so neither one can see what it looks like on the other side. But when you finish this, the student, and hopefully yours kind of looks like what is shown there as the example, but you're going to end up with something. Well, let me ask you, what do you think this figure looks like? So you can put something in the box, either one.
A
Which one do
ship.
you think is what this object looks like? And so Sally says a ship. And you could have students, think first, have them raise their hands if it's in class. Of course, this is a ship. Now, how is your figure different? Well, one thing, obviously we didn't go through all the steps. However, one thing, if you notice what's different, what did the communicator, in my case, and me, what did I forget to say right off the beginning? What mistake did I make that our base of our ship looks different than the actual figure we were trying to make? And so Sally said, rotate the, I forgot to say, rotate the rhombus 180 degrees. Excellent. And in this program, they actually have a protractor too you can use. And so using those descriptions, it's just a good way to introduce. So we're talking about ships here, but this is something you could do with trains, houses, birds, different animals, anything you wanted to. It's just a great intro that really gets into communication. And I wanted to highlight this because this is an activity that was inspired by a set sail PD at the U.S. Naval Academy in Annapolis, Maryland, which is the U.S. Naval Academy. And they have the STEM Center there. And you as a teacher, believe it or not, can go for totally for free. Everything's paid for. You could go to the Naval Academy for a summer professional development workshop. Totally, totally free. Now they have workshops for DoDEA teachers, but this particular workshop is for any teacher at all. So knowledge is powerful. You know about this, apply. I've done it. Another part that I play a role of Navy community partner. And so there's a lot of things that I've done with the Navy, but this is something that any educator can do. This activity can also lead into a woman, talking about a woman by the name of Raye Montague. And there's a great book that you can talk about depending on the level. But Raye Montague was the first person to actually design a ship with a computer, which I think is super cool. Not the first black person, not the first woman, the first person. And so, talking about Raye Montague during National Engineers Week, which is what we're in, or talking about Raye Montague during the Black History Month, this is a great introduction. And to be able to talk to someone that is a hidden figure is not really talked a lot during Black history. I've never in schools that I've been in seen Raye Montague mentioned. So I would highly recommend doing that, talking about her. She worked for the Navy. She wasn't in the Navy, but she worked for the Navy. And so I'm going to turn this over to Pat because Pat has connections to the Navy and all of his resources are going to be available through this link. And I'm going to make sure I stop this. I'm going to stop share. And Pat's going to be able to share his screen. And he's going to talk a little bit more about Raye Montague. He's going to talk about how to have students, and he'll go ahead and share his screen here. He could go ahead and show us how we can use TinkerCAD to introduce Raye Montague and also bring in more math terminology with having students design ships. So I'm going to turn it over to Pat, and you should be able, Pat, to share your screen.
All right. Thanks, Kelly. I want to thank everybody for taking the time to come out and work with Kelly and I today. I'm going to go ahead and share a PowerPoint with you. I am going to move through this slideshow fairly quickly. And the reason I'm going to do that is so that we have time to actually play with TinkerCAD at the end. So don't panic if I'm going through the slides real quick, because Kelly is going to post on the ICTM website. You'll be able to download this whole slideshow and look at it in your leisure when you get a chance. Okay, yeah. As Kelly mentioned, I work for the Illinois Math and Science Academy now. My first job out of college was to work for the Navy as an engineer. And I worked at Naval Sea Systems Command, which was the same organization that Raye Montague worked for, and we were working in the same building at the same time. The group I work for at IMSA does a lot of educator professional development. That's a quick QR code if you want to go check out some of the other things that we do. Today we're going to learn how you can show your students how to use computers to really design anything with TinkerCAD, but our example today will be ships. We're going to talk a little bit about that book, The Girl with a Mind for Math. You'll get to play with the software, and I'm going to give you the ability to download some engineering design challenges that I've created at different grade levels. So here's the book in question, and if it's a lovely book, and if you don't want to buy the book, you can also see on YouTube there's various teachers who have recorded them doing read-throughs, and some of those are quite amusing. Raye was an amazing person. I don't believe I've ever met her. We were working on different projects at the time. I'm sure we passed each other in the hall. As Kelly said, she was a pioneer in the field of computer-aided ship design. And as an African American woman at that time in a STEM field, she faced numerous obstacles. There's one painful page in that book where these young white male engineers with their glasses and crew cuts and narrow ties are mistaking her for a secretary and asking her to get them coffee. I do hope I'm not one of those people. I can't swear that I'm not, but I think about that every time I look at that page. All right. TinkerCAD is the software that we are going to use. It's a computer-aided design software, but it's very simple to use because it was designed for students and teachers. It's free. It's web-based, so there's nothing to download. Like any piece of software you might use in a classroom, you do want to test it out extensively with the hardware you'll be using before you launch into an activity with your students. Of course, your computer would need to have internet access. It's something that students can do at home. Once they experience it, they can play around with it at home. And technically, you can do it on a touchscreen device, although I find it very, very difficult. So I always recommend using a machine that has a mouse connection. Although I should also say that things that I find difficult, many of my students can do with no problem whatsoever. All right, there's that image up at the top there is pretty cool looking, and that's the type of thing that you can do with TinkerCAD. But that's not what we're going to do today. The projects that we have for elementary school in particular are going to look something more like that cargo ship on the bottom. That's just as complicated as it needs to be for them to engage with the various aspects of geometry, which are so useful to give them experience with. So I'm going to share with you some ship design challenges. They're all very, very similar at every grade level. What's different are basically the math standards that we require them to do. At fourth grade, they design a Coast Guard cutter. At fifth grade, it's a fleet oiler. This is a ship that carries fuel for other naval ships in a task force. At sixth grade, they design a fast sea lift ship. This is a cargo ship that carries supplies from one port to another. Also very useful during humanitarian crises when it can carry relief supplies. So TinkerCAD will give you a work plane like this, and if you look on the right-hand side, there's a palette of all sorts of 3D geometric shapes, and you basically just drag what you want from that palette out onto the workspace, and then you can manipulate it and change the shape and ultimately lump these things together to look like a ship. I'd start by dragging this red box down. You see these little squares at the edges and corners. Those are grab points. You can grab there with your cursor and stretch it and make it more rectangular. We're going to go for the body of a ship here, which we call the hull. So I've stretched that out. Now, fourth grade, we might say, hey, we need a railing around the top of this part of the ship so sailors don't fall over the edge. How much railing do we need? And then they get to calculate the perimeter. And of course, all of this is to scale. And if you actually click that rectangle, it will show you the dimensions there. Fifth grade, we can work in surface area. So if we need to order paint, ships are constantly being repainted. We need to know how much surface area there is on the top there so they can calculate that. By sixth grade, we're talking volume, and this is particularly important for any type of cargo ship because you want as much internal volume as you can get. All right. Now I've dragged a little green triangle here. That's going to be the bow of the ship, the very front, the pointy part. And you can change its orientation. You can rotate it. You can flip it. I've adjusted its size, slid it on there. Now that I have two pieces together, I can select them both and group them. And you'll know that they're grouped together because it will merge them together and show the color. So the next part of the ship I might want to add would be a piece at the stern, maybe the engine room. In this case, over on the right, rather than the simple shapes, I've gone to a search bar and typed in the word trapezoid because I wanted this green shape here to drag down. And of course, it comes onto the workspace. It's too big, so I would manipulate that, shrink it down, flip it over, slide it on, and group it together. So there's kind of the body of the ship, but we also need a place for the crew to live. So I drag another rectangle down, adjust its size a little bit. One of the challenges mentions, how much volume you need for each crew member. So you have to choose dimensions, kind of guess and check until you can get an appropriate volume. And then we'll sit that on side and attach it. And there we go. That's the type of ship any elementary school student can put together. Now, sixth grade, we're also talking about things like ratios and proportions. For a fast ship, you want to have the length to width ratio as long as possible, as great as possible. In this case, we had 139 millimeters by 24, and we could simplify that down as 5.8 to 1, or roughly 6 to 1, 6 times as long as it is wide. That would be a nice ratio for a cargo ship. You can download all of those challenges from IMSA Digital Commons, and this QR code will take you there. There will also, again, be links that Kelly will put on ICTM. These are the various science standards that get hit, and these are the math standards. You can look at those later. It all depends on which challenge you're using at what grade level. And if your school happens to have a 3D printer or you have access to one, you can save the files that you create in TinkerCAD and then actually print little ships, which students would enjoy very much if you have access to that. Now, those were the elementary challenges. For grades, higher grades, you get another challenge here where groups design different parts of a ship. A cargo ship, and they're responsible for communicating with each other because each group is going to design and print, if you have a 3D printer, a separate part of the ship. Now, not only do they need to meet those specifications, but they have to actually fit together and join together in a way that allows the ship to do what it's supposed to do, to carry cargo, to not sink. So here's a picture of, you could combine those all into one STL file and print it out as shown here. Here's an example. Now, this is an example of a ship that fits together perfectly. I guarantee your students will not get this the first time. Um, and the point of this activity is really to get into the communication. If one group designs their section wider than another so that they don't fit, how exactly did that happen? What did you tell the other group? Did you tell everybody? Did you just tell one person? Did you listen for feedback to hear that they repeated what you just said to get that right? Did you give them a drawing, a sketch? Can you show that? How clear is it? By really drilling into the details of how miscommunications happen, I think students can really learn a lot. Now, once you have something that fits together, you can take a 3D pen and use it basically as a welder. And here I've taken a 3D pen. I've used white plastic here just so that you can see the difference. And I've gone all around the edges, and it works more or less like a welder, except obviously a lot safer that any elementary student can do on their desktop if you want to mess around with 3D pens. And if you've never seen a 3D pen, at the end of this, I can show you what those look like. So now that it's put together, we want to paint it. The plastic used in 3D printers tends to be rather porous. So just like a real ship, it needs to be painted. I've used enamel model paint. Obviously, you don't want to use water-soluble paint. If navy gray is really not your favorite part of the color palette, another thing that works really well is fingernail polish. And I've seen some really beautiful ships with the most brightest, amazing colors from using nail polish. And after you have the ship all put together, the activity includes a number of tests you can do. It's supposed to hold a certain number of pennies in each cargo hold, and obviously float. There's tests for stability. How far can you tilt it to one side or the other without it flipping? And also testing it for strength. Doing a 3-point load test where you put a weight in the middle to see, how much it can stand before it snaps. So those are the different challenges that you have available at different grade levels. You're welcome to download them and play around with them. My contact information is at the beginning and end of the slideshow, so you can feel free to contact me anytime if you want to brainstorm about using TinkerCAD, either for this project or for anything. But let's go ahead and play around with it now. If you haven't yet, go ahead on your computer, get to tinkercad.com. And I am going to go ahead and let's see. I go ahead and get there myself. Okay. Kelly, do you see do I have TinkerCAD up? For some reason, I've
Yes,
lost.
I see your work plan.
Okay, thank you. It's not showing me that green rectangle that I'm used to seeing around it, but here we go. This is TinkerCAD, and it might take you a few clicks on the home screen. You'll have to establish an account. It's not difficult, but it takes a few steps. Now you have different options. You can just play around. That's fine. There are also a set of tutorials, and there's lots of them. Here on this slide, I've listed the ones that I think are the most useful. If you go through these tutorials, and they last about 5 minutes each, that's all your students or you would need in order to, build a ship. So if you like, at this point, you can either go through the tutorials, you can just play around and see what you can do, or I'm just going to build a ship myself and you can watch me do that, or any combination of those that you would like.
And I want to encourage you to, as Pat is doing a ship, ask questions. You can just unmute yourself and ask. Or if you don't feel comfortable doing that, please place it in the chat box and I'll ask. But if you have two screens, I know when doing like learning about how to do things on the computer, I always find two screens or two computers is very helpful so you can watch and then you got the other computer at the same time. That's how I always learn when I watch tutorials or when I'm creating an activity for students that involves the technology. So, can you kind of talk through us what you're doing as you're doing it, Pat?
Absolutely. I'm going to talk through every step, but again, don't hesitate to interrupt if you have questions. If I hold down the right mouse button, I can rotate this workspace around. And if I do shift right mouse button, I can translate it around. And that just helps you see it from different angles. I dragged a rectangle down. I click on it and I see all these different grab points here. I'm just going to grab one and make it longer, kind of look at it. That's a little taller than I want. So I'm going to reduce that from 20 millimeters down to about 12. There's a nice long segment. Maybe a little too long. Maybe shorten it up. And you can see the dimensions are showing live there as I move it around. Okay, that's a good start, I think. And I want to put a bow on the front of that, a nice pointy bit to help cut through the waves. So I'm going to grab this green triangle and drag it over here. It's not oriented the right way. So I'm going to go to these little bits here and they will allow me to change the angle and rotate it. And it conveniently likes to stop at 90 degrees, which is very helpful. Usually. There we go. Now let me slide that over there. How's
Hey,
it looking?
hey, Pat, do
Mm-hmm.
they tell you when you have completed your design if it will float or sink?
Um, with the simple ones that I'm making now, where it's just a solid thing, no, TinkerCAD wouldn't give you any indication whether it would float or sink. Now, yeah.
But maybe students after they make, if you're able to do a 3D, maybe you could go to a you know,
Absolutely put it in a sink. And what you'll see is that the plastic itself does tend to float, although if you design it this way, um, it will be top heavy and it will probably roll over. So now I'm just trying to get this so it kind of matches. Let's see, that's 18 wide, and that's 19 wide. That's why they're not fitting. All right, so we make that little adjustment. I'm just going to slide this all the way on. Whoops, now look at it from the side. Let me bring that up and make it a little lower. There we go. Maybe I want that a little bit sharper. Let's stretch it out there. All right, now to join them together, I'm going to click on this. Then I'll shift click on the other piece. And there's a button up here to group them together. And bang, there they go. They're together. Now we want to put a stern on the ship. Oh, what could that look like? There's lots of interesting shapes we could use. How about this one? We'll make a nice rounded stern. But I've got to stand this up. Bing. And let me turn it to face the right way. I'm going to slide it over here. I don't want it that tall. Let me bring it up so it's in the same plane. And bring the height down from 20 to, I don't know, 9. Kelly mentioned in chat that sometimes we land aircraft on ships too. If you want an area on the back for landing a helicopter on, let's stretch that out so it's nice and big. And I'll kind of move this up. Looks like it fits from that angle. Oops, it's a little wide.
Hey Pat, how do you know that they're actually touching?
That's a great question, Kelly. There is a tool that you can use that will line pieces up automatically. It's one of the more challenging things to use. So frankly, I just eyeball it. I put it up there and I look at it from every angle until it looks like it fits. And when I join them together, if I'm wrong, I'll see. I'll see a gap there. You can kind of zoom in on it. This looks like I think I've got that matched perfectly. Let's see. So I'll click on the piece I already have, and I'll click on the new piece, the stern, and we'll join those together. Yeah, that looks good. If it didn't fit well, you'd see a line here or some type of imperfection. So that's looking pretty good. Maybe I can add another piece here, part of the superstructure up top for usually where the crew lives. And the other equipment on there is probably up top. Whoops. Okay, I'm gonna lift it up and bring it over. Oh, I'm just playing around now, but okay, that might work. If it looks like a ship, you're probably doing good. How about that? Maybe we want something that looks like an ocean liner. Maybe students want to put smokestacks on it. We could do that too. Just shrink it down a bit.
And what I like here is all we're using terminology. A cylinder is representing the smokestack. We had these rectangular prisms. Um, we had what looks like maybe, I'm not sure what mentioned earlier, a trapezoid.
Mhm.
Mentioned that earlier, but also the like height. You could talk about the radius or the diameter or the width or the height. So lots of just being able to explain again, what you're doing. And you could have students make this, and also you could have them do a video that explains how they created their object.
True. You're only seeing the tip of the iceberg of what TinkerCAD is capable of doing. There we go. So I've been talking a lot and I haven't been hearing from anybody else. Is anybody uh, trying to make something have questions?
Well, people are hopefully having the opportunity to play and try building something. Pat, what was your role with I guess it was the Naval Sea Systems Command? Is that where you were?
Yes, I worked in the ship design and construction for two different classes of ships, the Ticonderoga class cruisers and the Arleigh Burke class destroyers. So a lot of it was office work, but I also did a lot of traveling to the shipyards where those vessels were being built. So it was a really, really exciting job for a young man fresh out of college. In fact, I actually did it during college. It was a co-op job. So the Navy paid for the last 2 years of my college, and what I'd do is I'd take classes a semester, and then I'd work for them for a semester. So they paid for the rest of my college, and then I had to work for them for 2 years afterwards as well.
What was that? Was that a SMART scholarship, quote unquote SMART scholarship, or was that a different certain scholarship that teachers can talk about with their students?
Oh my goodness. No, I'm not familiar with that phrase smart scholarship. It was I guess what I would say is to encourage young people to look for co-op opportunities while they're in college. And if you do co-op with the government, um, yeah, there will be some type of opportunity for you, um, to get part of your education paid for.
And I did put into the chat box information about the Department of Defense STEM scholarships, specifically SMART scholarships. This is a phenomenal thing that they'll pay for your entire schooling, plus students will get a monthly stipend, plus they get a job as soon as they graduate.
Yeah.
And just a shout out here to Daniel. Daniel and I actually we met at the Set Sail PD couple years ago now in Maryland, and he is commander of one of the Sea Cadets, uh, I guess squadrons. I might be using the wrong term, but Sea Cadets up in the Chicago area is where Daniel's from. And so there are Sea Cadets programs all throughout the United States that just like the Civil Air Patrol has an auxiliary for students connected to the Air Force. The Sea Cadets are connected to the Navy.
Oh, very cool.
Yes, thank you very much on that. Like I put in the chat, I haven't used a CAD program in 30 years, and this is really kind of neat. And being something free for them to play games with and actually try to learn from, definitely could be something we could use. They're kind of giving up on the ones out here are kind of giving up on the robotics portion as far as um, the STEM with the underwater robotic because they see that as a little mundane. They see all these robot wars and all these other things that everybody else is doing, and that's what they want to do now. So was it might be something else for them to use as a tool because it's all going that way now. And I even got into Copilot AI just recently, and it's an amazing tool what that can do. Just haven't been doing CAD yet.
Yeah, if anybody who's going into robotics, just making parts for the robot, being able to use a CAD program, and as simple as TinkerCAD is, it's the only thing I use now. This, when I'm doing projects, this does everything I'd want it to do. And I do want to show what you can do with negative space here. When you drag a shape out here, you have a choice of making a solid or making it a hole. Basically, when I move this over here and combine it with the other red part, um, it's basically going to subtract itself out. And that's how you could put a hole in something. Or in this case, I didn't really intend to make it all the way through the bottom of the ship. That would be a problem. Let me unlink it. Grab the hole. Let's see, make it not so deep. There we go. Need to raise it. There we go. Now that's how you can hollow out a space if you want to put cargo. A lot of the ships I designed in the one challenge were to carry pennies just as an easy, piece of cargo that you can count to see how many pennies it can hold and still float.
I know with the pennies no longer being made, that another
Oh, that's
option is
true.
is maybe paper clips. I know I tried kind of made the switch to paper clips, but I'm not sure if that would fit with how big these are. But that's another option with being able to count things that you might have a lot of. Um, if once the pennies probably give it another year, you're not probably going to want to use any of those pennies anymore because
True.
I like them.
Flat washers are good too, or nuts and bolts.
And then you can get into weight distribution, things of that nature.
Oh, absolutely. Yeah. Other questions? Has anybody made anything they want to share?
Look, I'm just looking at the ship that Patrick that you made. It makes me think of the Titanic. I mean, these are some things that I'm thinking of like novel engineering. If you teach other things besides STEM or math or science, what a great way to make something that is associated with a book or a historic object related to having your students make something that connects to what they're learning about in a social studies class. STEM can occur all across the board in every subject. It doesn't have to be quote unquote STEM class or math class or science or technology. Once we connect these to other subjects, those kids that really like this stuff might then get into those other subjects that maybe they're not as good at or they don't think they like as much. But if we can make these connections, having them, whether it's building a boat, a ship, a train, a car, there's lots of things, a house, there's lots of things. And one thing you can also do is you can find you can actually, as a teacher, anybody can, you can find other objects that have been made by other people. And you could actually, I'll say, quote unquote, hack it. I like that term because really you could take that's how ideas are improved. They take something that's built and you can tweak it and make it better. So that's something else that can be done is you don't even have to start from scratch. You could start with something else and change it to fulfill certain requirements.
Yes, absolutely. Not only can you save what you create here, and you want to be careful with this with students, but there is an online community where yes, people can share their work, and you can download other people's creations or a copy of them and deconstruct them and play around with them yourself.
And that's why I like the idea of having students, if they're going to do this for extra credit or as an assignment or whatever, I think also having them do a video that shows what they're doing and they explain it so you know they actually created it themselves. I think that's always a good thing. And they're working then on their communication skills of what they did.
Absolutely. They could easily make a slideshow pretty much exactly like the one that I made, showing step by step how it works, showing if you have them do any calculations for area or volume.
Now, in this object, Pat, this is in millimeters, correct? Can you show us if we wanted to change maybe the units?
Oh, that's a good question. I've only ever used millimeters.
Oh,
Let me see.
and
That
maybe
may
that's something that could be the students can figure out, but you probably want to use millimeters because you don't want it to be very big. And so I think that's why millimeters are often what's used. Um,
Well, yes, because what people most often use TinkerCAD for is to print things. So yeah, these come out a very convenient size for using with a 3D printer, and but also in naval architecture, things are drawn to scale, so it's opens up the ability to discuss. Okay, in our design here, this is 96 millimeters long, but at 1,000 to 1 scale, 96,000 millimeters. Well, that's 96 meters. So you can do that as well. Now, other things completely unrelated to what I've been doing that you can do with TinkerCAD. If you look up here where I'm moving my cursor, you see there's a pic here. Does anybody recognize that image? Welcome to Minecraft. So that's something students still, I think, are very much excited about Minecraft. So you can duplicate what you can build in Minecraft right here in TinkerCAD. Or if I click the Legos, this is how you could represent those ships with Lego blocks.
That's impressive.
So even if you don't have a 3D printer, but you have a bucket of Lego bricks, go build your ship. Or do the reverse, build it in the Lego and then see, well, what would that look like in a more realistic frame? Other things TinkerCAD can do, and this I've never used, but they have a circuit design setting on here. I'm trying to find where it is. You might have to go back out and start from the TinkerCAD page, but they let you design electrical circuits as well. I've never used the software for that, but I know it's here. Can anybody think of something else that's occurred to you that maybe your students would enjoy designing that could be done with TinkerCAD?
Well, something offset from the students. I've got a few autistic grandchildren that can work with this a lot better than some other things, and I think this would be fantastic in that area.
Yeah, absolutely.
I mean, TinkerCAD again could be done at all levels. I mean, you could just start with have them pull out the orange cylinder. I mean, having this terminology or just a cylinder. So they have to find the cylinder and bring it out. Bring out a cone. Put the cone, position is a very early childhood math thing. So put the cone on top of the cylinder. So these are things that, again, but depending on your level, or if you have special needs kids, these are things that you could just do to get them their hands on this. And you never know what kids can do if just given the opportunity.
I've been using the basic shapes library because I typically want students to learn basic geometry. However, there are other more sophisticated things in the library which, don't necessarily lend themselves to easy calculation, but can be very exciting if they want to, start building tractors. So there's a whole section on vehicles and machines, creatures and characters, so they can start making little people.
And this is where I really like the idea of connecting it to scale. So if you're going to do a model, whatever that height is, what would the height of a person need to be realistically? Or if that's your person in real life, how big would that person be? Kind of going the opposite way.
Yeah. No, I'm just really getting silly, but
Another suggestion, if you do something like this activity, is invite people from the community that use AutoCAD. They could be engineers, they could be technicians, showing different careers and different pathways. You could have someone who went to community college, has a great job, and uses AutoCAD, does drafting. You could have somebody who went 4 years or got their bachelor's or got their master's degree, an engineer, and they're using AutoCAD. And so, talking about the different careers that would use this, after talking about Ray Montague and talking about, you know, naval engineers, there are other types of engineers that can also use CAD in their design. Um, creating prototypes, smaller scale things, and they can run different tests on that then. And then you go to the manufacturing side of actually building larger versions of what has been made on a smaller scale within AutoCAD or in this case, TinkerCAD. But I would encourage you, this is just something that some kids will really they'll just love playing with it. But if you give them a task, once they accomplish their task, and this is a good example, they can then, show you that they did what they're supposed to do, and then they can explore and they can make other things. Um, I think that's a fine to do because it still gives them that creative opportunity and they're learning what can be done within that program beyond what the assignment was. Ultimately, also, they could help their classmates if they are done, they can go help their classmates out as well that might be struggling on building something or doing what the task required.
absolutely. Pretty much anything that you do with TinkerCAD is going to help development of 3D spatial reasoning.
Want to remind you that I will be sharing a link that you'll have access to the PDF. I will also have this video uploaded as well, so you have access to that. But all of Pat's resources will be linked, and this PDF, again, you'll have access to that. You also will have my email as well as Pat's email, and so you can feel free to contact either one of us. Thank you again for attending our PD on naval engineering in honor of National Engineers Week, as well as in honor of Black History Month. Thank you so much. Feel free to reach out to us and have a wonderful evening.